All right, so this is 3.2, which is multiplying radicals and rationalizing the denominator. These skills are needed mostly, not necessarily for just doing college algebra stuff, but if you are going on to like pre-calc or calculus, this is where you really need to know these skills. So just so that you know where things are used and everything, that's where these skills come into play. So we're going to start with multiplying radicals. And when we multiply, we're using the property, the product property of radicals, which is essentially if you're multiplying square roots, cubed roots, whatever, as long as the root is the same, so they match, you can multiply and combine them into one square root symbol or one cubed root symbol, one radical. You can also do the reverse, which is what we do when we simplify radicals. We generally break it apart and undo it. But when you're multiplying, you're trying to combine it. And whether you split it apart or combine it kind of depends on the context. Sometimes when you're simplifying, if you're simplifying multiple things, it's easier to combine them first and then split it apart. It depends. But what we're going to be looking at here mostly are like distributing and FOIL and those kind of things, where you're definitely going to be wanting to combine them first. So when you're working with radicals, all the same rules for distributing hold. Using FOIL, if you wanted to multiply using a table method, all of those rules still hold, even though you have these things with these square root and cube root symbols. Sometimes I recommend people replace the symbol and the number and everything just with a variable, do the math with the variable, and then plug stuff back in. Sometimes that's easier for some people. The other key thing is that we are going to be multiplying conjugates, and conjugates are where they have opposite signs. And when you do that, the radicals disappear. So when you're rationalizing the denominator later, you're going to be doing a lot of that because we want the square root symbol or the cube root symbol to disappear. So we're going to be deliberately multiplying by the conjugate so that we can remove that. So I'm just going to be starting with, some examples where we are multiplying without any variables. Then we're going to move on to variables. We're going to move on to FOIL. We're going to move on to distributing. We're just going to start small. So we're multiplying the radicals. Here we have 7 times 14 inside a square root. Or two different square roots. So you can combine these and have one square root, and you can put a 7 times 14. Now, in my simplify video that I have in the video section on the left side of the classroom, I go over how I simplify these things, and I always do it by prime factorization. Now, 14 is easy enough to factor as 2 times 7. So I'm going to just rewrite this as 7 times 2 times 7. So that 14 I'm just splitting up as 2 times 7. We have 2 7s here. So I can group those together because 7 times 7 is 7 squared. So I'm going to write this as 7 squared times 2. So I'm just combining the 7s together. There's 2 of them, so there's an exponent of 2. Now I'm actually going to split these apart because I want to split them apart so that I can have something that I can take the square root of. So I'm sort of undoing what I did, but I'm doing this with the purpose to simplify further. Because 7 squared, and then when you take the square root, those cancel out. A square root cancels an exponent of a 2, and you're left with what's underneath, which is just 7. So this simplifies to 7 times the square root of 2. So you can see that a lot of it was mostly just manipulating. I was rearranging things, splitting things apart in different ways, and recombining them in different ways that allow us to simplify. I'm going to do something very similar with the example on the right. We have 5 times the square root of 15 times 2 times the square root of 20. So I can rewrite this so that I can put the whole numbers together and then I can put the square roots together. So when you're multiplying things with radicals, the whole numbers, you can just multiply them together like you would anything else. So we have 5 times 2, so we have 10. And then I have the square root of 15 times the square root of 20. And I'm going to combine those, but I'm not going to actually multiply those together because I'm going to try to break them apart into primes so that I can simplify further. So 15 is 3 times 5, so I can break that up. And 20 is 4 times 5, and 4 is 2 times 2. So when I break these up in a product of primes, for 15 I'm going to have 3 times 5, and then 20 I have 2 times 2, so that's going to be 2 squared, and then times 5. So just like I did on the left example, because I have a 5 and I have a 5, I can combine those, I can put those together. So 5 times 5, that's going to be a 5 squared because there's 2 of them. And then a 2 squared. And then I have a 3 that's kind of left by itself. It doesn't really have anything. So now that I've done my product of primes, I've sort of grouped things together, and I want to group them in exponents of 2 because it's a square root. I'm going to start breaking those apart so that I'm taking the square root of 5 squared, and then I'm taking the square root of 2 squared, and then I have left over the square root of 3. So I have 10. When you take the square root of 5 squared, those cancel, so I'm left with just 5. Square root cancels the square on the 2, so I'm left with just 2. And all of those are multiplied together. So I end up with 10 times 5 times 2. So 10 times 5 is 50, times 2 is 100. So my final answer is 100 square root of 3. Now I'm going to throw some in with variables and cube roots, and actually fifth roots here, so you can see how the rules work when we have different, when they're not square roots, when there's something with different radicals. So I'm going to, for this first one on the left, I'm going to take the whole numbers and I'm going to group those together. So we're going to have -7 times 2. And then I'm going to group together the fifth roots. So -7 times 2, I can multiply, that's -14. And whenever I have variables, I always want to combine those together. So that's going to be x cubed times x squared into the fifth root. So they're both fifth roots, so I can combine those into the same symbol. Now with the fifth root, you want to group things in exponents of 5 because we want to try to cancel out the 5. So these exponents, when you multiply them, the exponents add. So I have my -14, I have my fifth root, and then my new exponent is x to the fifth because 3 plus 2 is 5. Now that 5 on the root cancels out with my exponent of 5. So the whole symbol and the exponents disappear. That's the reason we have radicals, is to cancel these things out. So I'm left with only what's underneath it, which is an x. So my final answer would be -14x when those all get canceled out. Now on the right, there is a cubed root. So I want to group things in 3s, exponents of 3s. Now, I don't have any numbers in front, so I want to put these underneath the same root, but I am going to group the numbers together. So I've got 2 times 4, so I'm going to put those near each other. I'm going to put the x's near each other, so I have x squared and x. which has an exponent of 1. And then I have a y squared in both of them. So that's going to be y squared and a y squared. So I'm just rearranging them and putting them in the same root so I can start simplifying. And I want to try to group things in exponents of 3 because I have a 3 on the outside. So 4 is 2 times 2, which is the same as 2 squared. Because I already have a 2 there, I can rewrite that as 2 to the 3rd, because between the 2 and the 4s, I have 3 2's right there. When I look at my x's, I have an x squared and another x. When I add those exponents, when you multiply, you get x to the 3rd. So I want powers of 3, so I'm going to do that. Now on the y's, when I combine those, I get y to the 4th. I want these to be grouped in 3's. So if I have a y squared times a y squared, that's y times y times y times y. And instead of combining as y to the 4th, I can group the first 3 together and then have a leftover y. Because I want to group these in 3's because it's a cubed root. I want my exponents to match the number outside the radical. So I'm just kind of doing some reshuffling there so that I have something with an exponent of 3. Now everything that has an exponent of 3 that matches the cubed root gets its own symbol so that I can simplify. Usually I skip this step once you've done this enough, but I think it's good to remind yourself what's going on here if you do this. And then that also leaves me with the y by itself in a cubed root. So because my root matches the exponent, all of these cancel out and I'm left with just the base, just what's underneath. So I'm left with the 2. I'm left with an x, I'm left with a y, and then I've left over a cubed root of y, because that couldn't cancel out. This stuff is tough for a lot of people, so don't feel bad if you are struggling with this. Okay, so now I'm going to move on to where we have to use the distributive property or we're using FOIL. Most of the time we don't do these with complicated things like we just did here. Most of the time it's just like one variable, they're not multiple variables. So I'm going to start with the one on the left here. We have 3 times the square root of 5, and then in parentheses 2 times the square root of 5 plus 4. So we're doing the distributive property. So the outside, 3 times the square root of 5, gets multiplied by the inside, 2 times the square root of 5, plus, and then we have to multiply 3 times the square root of 5 times 4. So I'm going to rearrange these so that I can put the whole numbers together and I can put the roots together. So I'm going to have 3 times 2. And then I have the square root of 5 times the square root of 5. And then I have 3 times 4, and then a square root of 5. So going left to right, 3 times 2 is 6. And I can combine the 5 times 5 into its own square root symbol. And 3 times 4 is 12. And then we have the square root of 5. Now 5 times 5, we want to write that as an exponent. That's 5 squared, which cancels out the square root. So because the square root cancels out an exponent of 2, I should actually finish writing this so you don't get too confused. That cancels out, so we're going to end up with 6 times 5 when that cancels out. So 2 square roots cancel each other out. The square root of 5, the square root of 5 is just 5. And then I still have this plus 12 times the square root of 5 thing going on. Then 6 times 5 is 30, so we end up with 30 plus 12 times the square root of 5. Now we can't combine these any further because one has a square root and one doesn't. So that's as far as it goes. But we're following the same rules of algebra. We're still following the rules for distributing. And then once we distribute, now we're basically simplifying each piece as far as it can go so that we have something smaller. So on the right, we have something that we're going to FOIL because we're going to do the first, outside, inside, last. So first, I'm going to have my -2 times the square root of w times 3 times the square root of w. Then I have my outsides. So I have my -2 square root of w times a -9. Now I don't have a lot of room here, so I'm going to just kind of go underneath it. I'm going to offset to the right so that it's not too confusing there. The inside terms, I have a -2 multiplied by the 3 times the square root of w. And then the last terms, -2 times -9. So I'm just writing all of that out. So you're going to want to get to the point where you can start doing some of this in your head. So like for the first part, we have -2 square root of w times 3 square root of w. I know that I'm going to have -2 times 3. So I know that's going to give me a -6. And then if you want, you know that times w is w squared. So you can just skip a couple steps and write it that way first, because you know that those are going to, a w times w is w squared, and you can combine them. This is especially handy when you have lots of steps like something like this. Next, I have my -2w times -9. So I can multiply the numbers. -2 times -9 is a positive 18. And then I just have a square root of w that hangs out. The next one is -2 times 3 square root of w. So -2 times 3 is -6. And then I have my square root of w. And then the last term, -2 times -9, is a positive 18. So now I'm going to start simplifying. So on the left, I have a -6. And then when you take the square root of w squared, those cancel and you're left with just w. Now these are like terms, but they both have a square root of w. So 18 minus 6 is 12. So this is going to be plus 12 square root of w. And then I have my plus 18. Now I can't go any further because I don't have anything else that matches. I have a w, but one is inside the square root, one's outside. So those are not like terms. So this would be your final answer by going through the FOIL process. So we're going to do lots of multiplying as we move on to rationalizing the denominator. It's going to be lots of practice. So basically, we don't like having square roots, cubed roots, any of those symbols in the denominator of a fraction. And so we get rid of that, and it's called rationalizing the denominator. They use the term rationalizing because square roots are irrational numbers. So when we remove them from the denominator, we're left with a rational number in the denominator. So that's where that term rationalizing the denominator comes from. And we're just trying to get rid of square roots, cubed roots, those things. We do this by multiplying the top and the bottom of the fraction by the conjugate. I should specify that it is the conjugate. Grab a different color here. a conjugate if two terms. If you have one term, you don't have to multiply by the conjugate. You can multiply by the same thing that you have. So this little note here is specifically for conjugates. Now that's most of the time when you have to do this. So that's why my note is referring to that, is because most of the time when you're rationalizing the denominator, you're doing it when you have something added or subtracted with the square root at the bottom. So I'm going to start with ones where they're not in that situation, just so you can see how this works. So it says rationalize the denominator. You may also see the word simplify, and that just basically means, okay, we don't want to have square roots in the denominator because we don't like that in simplified form. So I'm going to start, we have 1 over the square root of 7. So if you just have one term in the denominator that's a square root, you basically multiply the top and the bottom by what is in the denominator. So it's the same thing when you have a fraction and you're trying to build it to have a certain denominator, you multiply the top and the bottom by something. We're doing that here. And the reason why we're choosing the same thing is because the square roots will cancel. And we saw this on the previous example with the square roots of 5. Square root of 5 times square root of 5, it ends up canceling out. Square root of 7 times square root of 7, that cancels out. So you multiply straight across, so we would end up with the square root of 7 on top. And then in the denominator, you'd have 7 times 7, so that's 7 squared. And so you can see that square root cancels out the square. So you're left with the square root of 7 over 7, and that is considered rationalized. It's okay to have square roots in the top of the fraction, we just don't want them in the bottom. So you're basically multiplying the top and the bottom by whatever's in the denominator. So for the example on the right, we have the square root of 3t in the denominator, so we're going to multiply by the square root of 3t. And I always make sure to write that I'm doing the top and the bottom because it's easier to see. I'm multiplying straight across. So I'm going to end up with 9 times the square root of 3t on top. And in the denominator, I'm going to kind of group the things together because I have 3t times 3t. So I can combine the 3's. 3 times 3 is 3 squared. And I can combine the t's. T times t is t squared. So I can simplify the denominator. I can take those squares and separate them out, so I can take the square root. The denominator stays completely the same. And so I end up with a 9. The numerator stays completely the same, sorry, the top. So I have 9 times the square root of 3t, and then square root of 3 squared is just 3, those cancel. Square root of t squared is just t, those cancel. Now, we can actually reduce, because I have a 3 in the bottom and a 9 on the top, I can divide those by 3. And that would, because 9 divided by 3 is 3. So I'm going to be left with another 3 there. I cannot cancel out the t's because one is inside the square root, one's outside of the square root. So those can't cancel because they're not both outside. You can only cancel if they're outside. So when I simplify this, I'm left with 3 times the square root of 3t over t, and that is rationalized. So again, that t, those can't cancel because one's inside square root, one's outside. Okay, I'm glad. These are good news that it's still making sense. Okay. I've got another square root here, and then I've got a cubed root. The cubed root, those operate differently. So those are important, so you're going to want to pay attention to the one on the right. But first, let's look on the left. So I have the square root, and it's just one square root. So you might be thinking, but there's no denominator. Well, if I rewrote this, I split up the square roots, now we have a denominator to rationalize. We want to get rid of the square root of 3 part there. So we have the square root of b cubed over square root of 3. So there's a couple things that we're going to go on here. We're going to try to get rid of the square root of 3 in the denominator, but also that b cubed, we can simplify that further because we want powers of 2 on a square root, and there's 3 of them. So I know I can definitely cancel out 2 of them with a square root. So there's going to be a couple things going on here. But I'm going to start with the rationalizing part. So I'm going to multiply the top and the bottom by the square root of 3. And then I will just go to the right here. So I have the square root of 3b cubed. And then we have our square root of 3 squared. And I'll just continue going to the right here. 3b cubed. Square root of 3 squared. That cancels. We're just left with 3. So now we have this b cubed thing, which is b times b times b. Because we have a square root, we want them to be grouped in powers of 2. So I'm going to be grouping that as b squared times b so that I can cancel things out. So I'm going to have 3 times b squared times b over 3. Now the b squared part, I want to pull that off by itself so I can take that square root. And then I'm going to have my 3b inside. So I have my square root of b squared. Then I have my square root of 3b, and then it's over 3. So that square root and b squared, those cancel out. So that leaves me with a b times the square root of 3b over 3. And we can't cancel out the 3's because one's inside a square root, one's outside. So those cannot cancel. So cubed root, we got 2 over cubed root of 7. So the cubed root acts a little differently because if we want to cancel out the cube, we need to have exponents of 3. If I just multiply it by another cubed root of 7, there's only going to be 2 7s. There's not going to be 3. So I have to actually multiply it by the cubed root of 7 squared so that I can have 3 of them that will cancel out. So that's the tricky part there, is you have to make up the difference so that they're in exponents of 3. So then it's the same thing on the 2. I'm going to be multiplying by the cubed root of 7 squared. Okay. So, Sean, you're already lost. So I'm going to just, let's see. So we've got, okay, I lost everybody on that first step. So let's just erase that. Okay. Oops, I'm in the highlighter. I don't want that. Okay. So this cubed root of 7, we want to cancel out that cubed root. In order to cancel out something that has a cubed root, we need an exponent of 3. If we do the cubed root of 7 times the cubed root of 7 like we were just doing, we end up with the cubed root of 7 squared. We do not have an exponent of 3, so it does not cancel. So we do instead is we multiply it by 7 squared, because then we have 3 of them. And that will now cancel out. So you're trying to make up the difference. You need to get it so that the exponent matches the root. So that is why we're going to multiply this by the cubed root of 7 squared instead. So when we do that, we're going to have 2 times the cubed root of 7 squared. And then in the bottom, we end up with the cubed root of 7 cubed, because 7 times 7 squared, there's now 3 of them. So on the top, because you add the exponents and multiply, and yes. So if I add an exponent of 1 plus an exponent of 2, that gives me 3 total. So on the top, usually we don't leave it as 7 squared if we don't reduce it, because I can't do anything there. So we'll actually square it and say 49. And then the cubed root and the 3 on the exponent cancel, and we're left with 7 in the denominator. And I cannot cancel out that 7 with the 49, because the 49 is inside a radical symbol. The 7 is outside the radical symbol. Yay, got it, yay. Are there questions? Okay, there's gonna be more of these, don't worry. This is not the only example I have like this. I have one with a 5th root. So same sort of idea here. We have a -2 over the 5th root of 5. So same idea. If we have a 5th root, well, I think I said 5, of y, we need to have an exponent of 5. So what we need to do is multiply it by y to the 4th, so that when you add them, you now have 5. So we're trying to get them in groups of 5, so we're no longer just multiplying by y, or even in this case, y squared. We have to do by y to the 4th, so that it gets us to 5. So that's where you guys got stuck before. Does that make sense? Okay. So, and you could just ignore that. That negative in front doesn't have any relation on what we're doing here. So I'm multiplying the top and the bottom by the 5th root of y to the 4th in order to get those denominators, so that I can have y to the 5th in the bottom to cancel out. So I'm going to just put the negative on top with the 2. So I have a -2, and then the 5th root of y to the 4th. And then in the denominator, y times y to the 4th is y to the 5th, because you add the exponents. So we have the 5th root of y to the 5th. So that 5th root cancels out the 5. So then we have -2, 5th root of y to the 4th over y. And so now we don't have that radical symbol in the denominator anymore. So now let's look at the one on the right where we've got the cube, and then we have the 5 and the z squared. So I'm going to just start by rewriting the whole thing. We're going to split it up so that we have the cubed root of 5. Oops, not the 5th root. Cubed root of 5 and the cubed root of z squared. So we have a cubed root, we want powers of 3. In this case, we have 2 z's already, so we only need to multiply by 1 more to get to 3, because 2 plus 1 will get us 3. So in this case, I don't have to do the square. It's all about how many more do you need so you have the, oops, I need to make sure that I can't talk and write at the same time sometimes. It's all about how many do you need so that you can have the exponent match what your root is. That's the goal. So in this case, we only needed 1 more so that we have an exponent of 3. So when I multiply these together on the top, I can put those inside the same cubed root. And I know that 5 and z, I can't do anything because they don't have any exponents on them. So they're certainly not going to cancel out. So it's just the cubed root of 5z. And in the denominator, a z squared times z is z cubed. So I'm going to have a cubed root of z cubed. And if I said fifth root, I'm sorry. All of these numbers are messing. I may be writing the right thing and saying the wrong thing. I apologize if that's confusing you. So we've got the cubed root of 5z over the cubed root of z cubed. So now the cubed root and the z cubed, those can cancel. So that way I just have a z in the denominator. And then in the numerator, I have my cubed root of 5z. You might actually pass the quiz. I hope so. Always do more practice, though, because you probably will forget in the next 5 minutes. It's always good to keep practicing. Okay, so now these are the ones where we want to do the conjugate. We've got a plus and a minus. And Sean, I only say more practice because you can never have too much practice, and you need practice to keep it in your. So even if it's just rewriting everything that you did here just to keep it in your brain, there's something about washing that then you have to then redo that process on paper yourself in order for it to stick in. I don't know, something about the way that math works, I guess. So these problems where we've got something with we've got numbers and radicals here. So we're rationalizing the denominator again. And this time we're multiplying by the conjugate, where it's basically the same denominator, but you want to have what's the square root part have the opposite sign. So for example, if the denominator is 4 minus the square root of 3, I want to multiply by 4 plus the square root of 3. And I want to do that on the top and the bottom. So those are conjugates, and we do that because the inside terms will cancel out. So this goes back to the difference of squares when we were multiplying. And if you have a plus b times a minus b, the insides can cancel and you're left with a squared minus b squared. So that's what we're doing here. It's going to cancel out the square roots completely. They're going to add to 0 essentially, and then that just leaves us with whole numbers. Now you do have to do FOIL here, so you want to keep track of everything. So on the top, I need to distribute because I'm multiplying 6 through the parentheses. So I have 6 times 4, which is 24. And then 6 times the square root of 3. So those just get attached together. The denominator here, so we're going to FOIL. So first, I'm going to do 4 times 4. So that's 16. Now I'm going to do the outside, so I'm going to do the 4 times the square root of 3. So that's 4 square root of 3. Then I'm going to do the insides, negative square root of 3 times 4. So we usually put the number first. So that's going to be a negative 4 and then the square root of 3. And then the last term is the square root of 3 times the square root of 3. And we have this minus. So we know that that's going to give us 3 squared inside the square root, because 3 times 3 is 3 squared. So I did first, outside, inside, last. So now we start simplifying. So I still have 24 plus 6 square root of 3 on top. I have 16. I have 4 square root of 3 minus 4 square root of 3. So those cancel. So those are 0. So I don't have those anymore. And then the square root and the 3 squared cancel. So I'm left with a 3. So that gives us 16 minus 3. So we end up with 24 plus 6 square root of 3 over 13. Now, some people will write it as 24 over 13 plus 6 over 13 square root of 3. So some people like to split that up into 2 separate fractions. I usually only do that if I can reduce, but neither of those fractions reduce, so I usually don't take the time. But some people do split that up so that they have them not in a single fraction. Are there any questions on this example I just did? Okay. So the second one on the right, we have a negative, and then we have 12. So if we want, we can put that negative up with the negative 12. And then we have, oh, Kyle's taking a screenshot. That's a good idea. That's a good idea to do that. Now the denominator, we have square root of 5 minus 3. So I'm going to put parentheses here because we are going to have to FOIL. Now you want to put the opposite number in front of the square root usually, but because of the way FOIL works, you can also switch the sign of the whole number and it will also work that way. So we could multiply by the square root of 5 plus 3 and it will work the same way, as long as you've just changed one of the signs. Not both of them, just one of them. So I'm going to put the negative with the 12. So I'm going to have a negative 12 times the square root of 5. And then that negative 12 times 3, which is negative 36. So that's what I've got on top. Now in the denominator, we're going to FOIL. So first, in this case, is square root of 5 times the square root of 5. So that's going to give us the square root of 5 squared. Now the outside is the square root of 5 times 3. So that's going to be plus 3 square root of 5. Then we have the inside minus 3 times the square root of 5. So minus 3 square root of 5. So you can see that those are going to cancel. And then our last term's negative 3 times 3, so that's minus 9. And I have to keep drawing my fraction there to make sure it covers everything. So on top, I have negative 12 square root of 5 minus 36. The square root of 5 squared got canceled, so that's going to be 5. 3 square root of 5 minus 3 square root of 5, those cancel, those add to 0. And then I have a minus 9. So I'm going to just move to the right here. I have a negative 12 square root of 5 minus 36. And then 5 minus 9 is negative 4. Now in this case, I am going to split it up as separate fractions because I know that I'm going to be able to reduce in doing some division. So if I rewrite this as negative 12 square root of 5 over negative 4 plus negative 36 over negative 4, I can do some reducing. I can start dividing. So a negative 12 divided by negative 4 is a positive 3. So this leaves me with 3 square root of 5 plus the negative 36 divided by negative 4 is 9. So that gives me a plus 9. So in this case, I did split it up because that allowed me to simplify and get whole numbers out of there instead of fractions. Whether you have the square root at the front or the back, it doesn't matter, as far as you could write it 9 plus 3 square root of 5 if you wanted. That's equivalent. Are there any questions? Oh, a lot of good, excellent. I'm glad that this is making sense. Okay, so if I can get it to switch to the next slide. These are my last 2 examples, and then we'll be all set for this section. You can see that these are a little more complicated. I have multiple square roots in the first one, and the second one I have a square root on the top and the bottom. So they are going to be more complicated, but the idea is the same. So first one, we have the square root of a minus the square root of b. So we are going to multiply the square root of a plus the square root of b so we can switch out those positive and negative signs. And then I need to do that on the top as well. So on the top, I'm going to distribute 6. So I'm going to get 6 times the square root of a plus 6 times the square root of b. That was a terrible straight line. In the denominator, we're going to FOIL. So first, we have the square root of a times the square root of a. So a times a is a squared. So I'm going to get the square root of a squared. Then outside is square root of a times the square root of b. So I'm going to just combine those as square root of ab. Inside, we have minus square root of b times a. So I can also write that as ab because the order of multiplication doesn't matter. So I'm just going to put them in ab order. And you can see that those insides are going to cancel out. And then the last term is the negative square root of b times the square root of b. So that's going to be a negative. Then we have our square root, and b times b is b squared. So top, we have 6 square root of a plus 6 square root of b. In the denominator, square root of a squared cancels, so we're left with a. Square root of ab minus square root of ab, those cancel. And then we have minus, and our square root and the b square, we're canceling those out, and we're left with just a b. We're not going to split anything up in this case because we have more than one thing in the denominator. If you have more than one thing in the denominator, then you don't split it up, you just leave it the way it is. If there was something we can cancel out by factoring, we would, but there's nothing here to cancel out. So that's our final answer. Are you guys able to hear my dog barking, or is she far enough away that you can't hear her? I'm just curious. You can? She's being really loud. Oh, Kyle can't hear it. So I guess it depends on how loud your volume is. Yeah. She's very sad because I didn't give her much attention yesterday because I had my headache, so she's very sad, and so she's like, when are you gonna be done? She is a hound mix. She kind of looks like she's kind of a lab, kind of a German Shepherd-ish kind of mix because she kind of has the hair like a German Shepherd, but she has the coloring of not a black lab, but like a golden lab or something like that. So she's some sort of mix. Her name's Liberty. So she is, we've had her about a month now. She is still in training. We're still trying to teach her tricks and teach her stuff. All right, with that distraction, last problem. We have 10 minus the square root of t over the square root of t minus 6. So same process. We want to do the opposite on the denominator, not the top. So we're going to multiply by the square root of t plus 6. And I always make sure I put these in parentheses so that you remember that you need to FOIL. Because if you don't do that, it's very easy to forget that you have to go through the FOIL process. So I'm going to start FOILing on the top. So I have 10 times the square root of t for the first. Now the outside is going to be 10 times 6, so that's 60. The insides have a negative square root of t times the square root of t. So I'm going to have my square root. T times t is t squared, so I'm going to write that. And then the last term's negative square root of t times 6. I don't normally do my foiling with all the arrows on the top, but since I'm also foiling on the bottom, I'm just kind of smushing them in there. If you're doing this in your own notes, you could do the FOIL separately, like to the right of your problem, and then write your answer underneath the problem. You could do that instead, but I don't have the room for that. Okay, so that's the top. Now I'm going to FOIL on the bottom. So I have the square root of t times the square root of t. So those are going to give me the square root of t squared. Then I have the square root of t times 6, so that's plus 6 square root of t. Then inside, it's negative 6 times the square root of t, so it's minus 6 square root of t. And then the last term is negative 6 times 6. That's a negative 36. So now you're going to start simplifying. On the top here, this 10 square root of t minus 6 square root of t, those we can combine, 10 minus 6. So that will give us 4 square root of t. Then we have our plus 60. And then the square root of t squared cancels and we're left with just minus t. Now in the denominator, we have our square root of t squared, so that cancels. We're left with t. We have the 6 square root of t minus 6 square root of t. Those cancel. Those are 0. And then we have our minus 36. And we can't go further. We cannot cancel out the t's because there's things added or subtracted. You can only cancel if they're multiplied, but because we have plus or minus signs in between here, those are not allowed to cancel. And we can't cancel out like a 4 out of the 36 or anything like that because, again, we have pluses or minuses. We would have to factor everything first, but there's nothing we can really factor out here. So that's as far as it goes. What order you write those things in doesn't really matter. What matters is that you've at least got them all written down.